Okay, I'm going to work out some integrals here for you involving radicals to help you finish your homework there and get some practice. I've been interrupted about 17 times, so hopefully I'll be able to get through this one. All of these integrals involve radicals, and let's start with the most basic radical function. We'll find the integral of the square root of x dx. And normally when we see a radical, it makes us want to run and hide. But I think after we do a couple of these, you become comfortable with them and they won't be so scary. What we need to do is change this into a form that will allow us to apply the rules that we already have. And the main rule we're going to use is that power rule for integrals. And so in order to do that, we need to take the square root of x and change it to be a power of x. Think back to your algebra 1 days. The square root of x is equivalent to x to the 1/2 power. The other thing that's scary about these problems is that we're going to have to get a little bit of practice and get pretty good at adding fractions together because you remember that the power rule for integrals says that to find the antiderivative of this function, what we do is kind of the opposite of finding the derivative. It's the antiderivative. And so what we do is we take the power and add 1. In other words, 1/2 plus 1. Of course, we have to add 1 in a form that has 2 as a denominator. 1/2 plus 2/2 is 3/2. And once we have the new power, then we're going to divide by the new power. And instead of dividing, we will multiply by the reciprocal. So the 3 over 2 is the new power, and now we're going to multiply by the reciprocal of that, which is 2 over 3. And add our constant, and we're done. Except that it's nice to be able to go back and forth with fractional exponents and radicals. And since we started this problem with a radical, probably a good idea to finish the problem in radical form. So what we want to do is take this x to the 3/2 power and write it as a radical. Now, remember that the number on the bottom of the fraction, the denominator of the fraction, is the root. The number at the top, the power, the numerator, is the power. So, you write this in radical form, what we're going to have is the square root of x to the 3rd power plus a constant. Okay? And that is the integral, the antiderivative of the square root of x. Now let's go on to the next one. This is number 13 on page 121 in your study guide. And this one involves other radicals that are not square roots. We'll find the integral of 2 times the cube root of y minus 4 times the 4th root of y dy. One thing that's different about this is that instead of x that we've been working with all along, we have a integral involving y, but that's okay because dy is the variable of integration, and as long as this dy agrees with this variable, then we can proceed in the same way. So what I want to do with this is separate this into 2 separate integrals as we've done before. We have several terms, in this case 2, separated by plus or minus. We can distribute this dy in a sense and write this as 2 separate integrals. And so what we'd get then is the integral of 2 times the cube root of y dy minus the integral of 4 times the 4th root of y dy. Okay, so there's one rule that we have at our disposal. We can separate multiple terms in the integral into separate integrals. The other rule that we've dealt with a bit is the constant multiple rule. This 2 is a constant multiple that can come out of the radical, so we don't have to deal with it at all until the end. And this 4 is a constant multiple, and that can come out. And that will allow us to just concentrate on finding the integral of the cube root of y. Okay, so here's what we have so far. 2 times the integral of, now, the cube root of y. We want to change this, as we did in the previous example, change this to be a power of y. The cube root of y can be written as y to the 1/3 power dy minus 4 times the integral. Now, the fourth root of y we have to write as a power of y. Again, that would be y to the 1/4 power dy. Okay, and now we can go ahead and find the antiderivative of y to the 1/3. We'll still have this 2 here. And now we want to apply that power rule for integrals, which is to take the power, 1/3, add 1 to it. 1/3 plus 3/3 would be 4/3, and then multiply by the reciprocal, which is 3/4. Minus 4 times, now the antiderivative of y to the 1/4. We'll add 1 to the power, 1/4 plus 1, that is 1/4 plus 4/4 is 5/4, and then divide by 5/4. But instead of dividing by 5/4, we multiply by the reciprocal, multiply by 4/5, and add a constant at the end. Okay, we can clean this up a little bit. Multiply our constants together. 2 times 3/4 is 3/2 y to the 4/3 power, minus 4 times 4/5 is 16/5 y to the 5/4 power, plus a constant. And again, we should put this, we began in radical form, we should put our answer back in radical form, and we get 3/2. Now, this is a cube root of y to the 4th power, minus 16/5 times the 4th root of y to the 5th, plus a constant. And there's number 13. While we're doing so well here, let's go on and do one more. And that would be number 14 on page 121 again. These only look more and more complicated. If you break the problems down into smaller parts, you can usually find a way to deal with them. I'm looking at this and I'm thinking, well, I don't think we'll have much trouble with this x to the 2/3. This will give us a little trouble. This is both a fraction and a radical. So let's just break this down into parts. First of all, let's separate this into 2 separate integrals so we can deal with them separately. 1 over the square root of x dx minus integral of x to the 2/3 dx. Okay, let's take on the hard part first. And that is this. First of all, we already know that the square root of x is x to the 1/2. We can go ahead and do that. This is 1 over the square root of x is 1 over x to the 1/2 power. Okay, and now here we have a reciprocal. 1 over x to the 1/2. We can write this with a negative exponent. And so we'll rewrite this one more time as x to the negative 1/2. Remember that the negative exponent means reciprocal. So 1 over x to the 1/2 is equivalent to x to the negative 1/2. And this is the argument of the integral. We're going to integrate x to the 1/2, a negative 1/2, I'm sorry, dx. And let's just bring this all the way down here. Minus the integral of x to the 2/3 dx. Now we'll deal with this in exactly the same way. This first integral, the antiderivative is to take the power and add 1, negative 1/2 plus 1, in other words 2/2. Negative 1/2 plus 2/2 is a positive 1/2, x to the 1/2 power, and then multiply by the reciprocal, which is 2. And so the integral of x to the negative 1/2 power becomes 2x to the 1/2 power minus, and this one was a little, this is a 2/3 here, this is a bit simpler. We'll take our x, the integral, the antiderivative of x to the 2/3 is x to the 2/3 plus 1, x to the 2/3 plus 3/3, x to the 5/3, divided by 5/3, in other words, multiplied by the reciprocal 3/5, plus a constant. Let me just write this again. Our integral, our antiderivative is 2x to the 1/2 power minus 3/5 x to the 5/3 power plus a constant. And to put it back in radical form, this becomes 2 times the square root of x, x to the 1/2 power is the square root of x, minus 3/5 times the cube root of x to the 5th plus a constant, and that's that.